Hello, I'm Dr. Steve Warner, and today I'm going to talk about exponents. So if x is any real number and n is a positive integer, then the expression x to the n means to multiply x by itself n times. X is called the base, and n is called the exponent. Let's look at some examples. 2 to the 1 is just 2. 2 squared means multiply 2 times itself twice, so we get 2 times 2, which is 4. 2 to the third means multiply 2 times itself 3 times. 2 times 2 times 2 is 8. 3 to the fourth, that's 3 times 3 times 3 times 3, or 9 times 9, which is 81. And x to the fifth means multiply x times itself 5 times. X times x times x times x times x. Note that raising any number to the power of 1 always just gives the number we started with. So x to the 1 is always just x. Also, by definition, raising any non-zero real number to the 0 power always gives 1. X to the 0 is equal to 1. Okay, let's look at an example. Let's compute 2 to the third times 2 to the fourth. Well, 2 to the third means multiply 2 times itself 3 times. 2 to the fourth means multiply 2 times itself 4 times. Notice that we're just multiplying 2 times itself 7 times. And when we do that, we get 128. This example leads us to the following rule. When multiplying two expressions with the same base, we can add the exponents. So in other words, x to the a times x to the b is equal to x to the a plus b. Let's look at another example. We'll compute 7 to the 8th over 7 to the 6th. 7 to the 8th means multiply 7 times itself 8 times. 2, 3, 4, 5, 6, 7, 8. And 7 to the 6th means multiply 7 times itself 6 times. We could cancel, and we just get 7 times 7, which is 49. Notice that when we did 7 to the 8th over 7 to the 6th, we wound up with 7 squared. This leads to the following rule. When dividing two expressions with the same base, we can subtract the exponents. In other words, x to the a divided by x to the b is equal to x to the a minus b. Okay, let's express x to the third to the fifth using only one exponent. Well, raising something to the fifth means to multiply it by itself 5 times. So we have x to the third times 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 x to the third. And x to the third means multiply x times itself 3 times. So we have x times x times x, x times x times x, x times x times x, and we have 5 of these sequences. Okay, notice that we're multiplying x times itself 15 times. That leads to the following rule. When raising an expression to an exponent, then to a second exponent, we can multiply the exponents. So x to the a to the b is equal to the x to the a times b. Here's a little review of the laws of exponents we just covered, plus a couple more. So remember that x to the 0 is 1. X to the 1 is just itself, x. When we multiply two expressions with the same base, we can add the exponents. When we divide two expressions with the same base, we can subtract the exponents. And when we raise a power to another power, we can multiply the two powers. Two other simple rules. Xy to the a is equal to x to the a times y to the a. And x over y to the a is x to the a over y to the a. Let's look at some more examples. 5y to the 4th times 11y to the 4th. Okay, well, we could just rearrange the product here to write it as 5 times 11 times y to the 4th times y to the 4th. 5 times 11 is 55. And here we're multiplying two expressions with the same base, so we can add the exponents, 4 plus 4. So we have 55y to the 8th, which is choice D. Okay, here's another example. Y to the 7th to the 4th is equivalent to what? Well, here we can just multiply the two powers. 7 times 4 is 28. So we get y to the 28th, which is choice A. Let's look at this more complicated example. The expression negative 5x to the 4th times 4x to the 7th minus 3x cubed is equivalent to what? Okay, well, we're going to start this off by distributing. So we do negative 5x to the 4th times 4x to the 7th. Minus times minus is plus 5x to the 4th times 3x cubed. Okay, and now as we did in the last example, negative 5 times 4 is negative 20. X to the 4th times x to the 7th, we could add the powers to get x to the 11th. And for the next term, 5 times 3 is 15. And x to the 4th times x to the 3rd, we add the powers to get x to the 7th. And we see that the answer is choice A. Here's another useful property of exponents. If x to the a is equal to x to the b, then a is equal to b. Let's look at an example. If 2 to the 5x equals 2 to the 3x plus 12, then x equals, well, by this last property, since the bases are the same, so are the exponents. So we have 5x equals 3x plus 12. And now we just have to solve this simple algebraic equation. Let's subtract 3x from each side to get 2x equals 12. And finally divide by 2 to get x equals 6. Here's an example that's a little bit harder. In the real numbers, what is the solution of the equation 4 to the x plus 2 equals 8 to the 2x minus 1? In this particular problem, the bases are not the same, but we could easily make them the same since 4 and 8 have a common base of 2. In other words, 4 is equal to 2 squared, and 8 is equal to 2 cubed. So we could rewrite these expressions as 2 squared to the x plus 2, and on the other side of the equation, 2 cubed to the 2x minus 1. Now we use the property of exponents that we learned before of raising a power to a power. This allows us to multiply the powers. So we get 2 to the 2x plus 4. Note that when we multiply 2 times x plus 2, we need to distribute. We get 2x plus 4, not 2x plus 2. Same thing on the right. we get 2 to the 6x minus 3. Now that the bases are the same, we can set the exponents equal to each other. 2x plus 4 equals 6x minus 3. Okay, I'm going to bring the 2x over to the right by subtracting, and the 3 over to the left by adding. So we have 7 is equal to 4x. Finally, divide each side by 4 to get that x is equal to 7/4. This is choice E. Okay, let's move on to negative exponents. By definition, x to the power of minus 1 is the fraction 1 over x. For example, 5 to the minus 1 is equal to 1 over 5. If you want to write that as a decimal, you can just use your calculator, divide 1 by 5, and you'll get 0.2. Both of these answers are correct. More generally, x to the minus n, by a rule we had before, when we multiply powers, we could write that as a power to a power. So we could rewrite this as x to the n to the minus 1. And from what we just learned, that's equal to 1 over x to the n. So to summarize, x to the minus n is just 1 over x to the n. So for example, 3 to the minus 4 is equal to 1 over 3 to the 4th, which is 1 over, well, 3 to the 4th is 81. 3 times 3 times 3 times 3 is 81. Okay, let's talk about fractional exponents. X to the 1 over n is the nth root of x. So for example, which of the following is equivalent to 8 to the 1/4? Well, 8 to the 1/4 is the 4th root of 8. That's choice B. Here's a summary of negative and fractional exponents. X to the minus 1 is just 1 over x. X to the minus a is 1 over x to the a. X to the 1 over n is the nth root of x. And finally, x to the m over n, this combines an exponent with a root. So the n in the denominator is the root, as can be seen here, and the m stays as an exponent. And this can be written in two ways, either as the nth root of x to the m, or the nth root of x all raised to the m. They're equivalent. One more example. The quantity, the nth root of 5 to the x, is defined when n is an integer greater than 2 and x is any non-zero real number. Which of the following is a relationship between n and x that will always make the nth root of 5 to the x a positive integer? Well, this problem becomes a lot easier if we rewrite the root as a power. So we're going to change the nth root of 5 to the x using the last rule to 5 to the x over n. So we want to know when this will be an integer. Well, the expression 5 to the x over n will be a positive integer precisely if the exponent is a positive integer. And the exponent here is x over n.